In this video, I'm going to be discussing the bisection method. So the bisection method is a very useful tool in order to determine the roots of a function. So the first thing you need to do in a bisection method is you need to pick lower and upper guess. So usually these will be given to you. For example, your professor might write that he might say that the lower bound of a function is equal to a certain number. So let's say you're given a function. Let's say your function was sine x, and then your professor would write the lower bound. He might denote it by xl, or he might just say the lower bound is, for example, 1. And then xu, I like to denote xu as the upper bound, and he might say that the upper bound of the function is 2. So xu is representing the upper bound, xl is representing the lower bound. And your professor will usually give you this. In most cases, they have to give you this in order for you to know what the lower and the upper is, and to determine the roots on this basically on this bracket. So the first step, as I just mentioned, is to pick the lower and upper guess. These will be given to you. The next step is to determine the estimate. So what you're trying to find is you're trying to find XR in this case. XR is very simple to find. You just take your lower bound and then you add that with your upper bound and then you divide by 2. To find the relative error of this, you would just do your the XR, the new term you found minus the previous XR, and then you would divide that all over your XR, the one you're just doing in this example. The one you just calculated. So all this might seem confusing. Yes, these are just words at this point. It's going to be much easier if you see an example. In the next video, I'm going to show an example, but in this video, I'm just discussing the theory and basically what the steps you need to do in order to successfully solve a bisection method. The third step is you need to evaluate. So make an evaluation. If you make an evaluation, you're looking for a couple things. So the first thing is you're trying to see if your function xl times your function xr is less than 0. If it's less than 0, you're going to get that your new value of xu is going to equal to your value of xr. If it's greater than 0, xl is going to equal xr. As I mentioned, all this is pretty confusing because it's just words at this point. It's not an example. If you want to see an example, there's a playlist. If you're new to this channel, there's a playlist that's going to show you another example, or it's going to show you an example on the bisection method. And then here what we have, if xl multiplied by xr is equal to 0, you would just go ahead and end it. So if you were to go ahead and then you were to set up a table for the bisection method would be very useful to solve. I highly recommend making a table. The first thing for making a table is you would have your number of iterations, so number of it, and that's your number of iterations. Your next thing you would do is you would set up your XL. After your XL, I highly recommend doing this. Your function, the function evaluated XL, and then XU, and then the function evaluated XU, and then you need to calculate your XR here. And then to calculate your XR, as I mentioned above, if we look here, XR is equal to XL plus XU all over 2. And then this is your value for XR. And then you would evaluate your function XR, and then you would go ahead and you would multiply XL times XR. So this is a very useful table I have created for solving the bisection method. It's a very simple one. In the next video, I'm going to go ahead and I'm going to do an example on I'm going to use a function and I'm going to evaluate the bisection method in order to calculate the root. So thank you for watching this video. Please continue on to the next video to see an example.